Greetings everybody. So today in this video we'll be learning about two things called permutations and combinations. Okay, so I'll give you the definitions of each one, give you some examples, and show you the basic calculations. Okay, so a permutation is an ordered arrangement of objects. So here I've got the letters A, B, and C, but they're arranged in two different ways. So each of these strings has the same letters in it, A, B, and C, but the arrangement is different. So what we would say in this case is that there are two permutations of the symbols or letters A, B, and C. Because in permutations, we have differentiation by order. Okay, so even though they have the same symbols, because the order is different, we would say there's two permutations. All right. Now you could think in short that for a permutation, the order matters. The order makes the difference, and that will be a clue later for solving problems. We might look at a problem and say, well, does the order matter here or not? Okay. But let's give another example. Like, say we have the symbols A, B, and C. How many permutations total are there of the symbols A, B, and C? So here I just went and listed them. Okay, just to give you an example without doing any math yet. So in a permutation, the order matters. So any different arrangement of the letters A, B, and C would be considered a different permutation. So here's all the ways that you could arrange differently, where the order is different, the symbols A, B, and C. That's all of them. And so we would say that there are 6 permutations of the symbols A, B, and C. Okay, now that in brief is what permutations are. The next thing is a combination. All right, a combination is an arrangement of objects where the order is not important. The order does not distinguish anything. We wouldn't say because two different strings have the same symbols but different order that they were actually different. Okay, so here's an example. We got A, B, and C, and B, C, and A. So each of these have the same 3 letters, but the order's different. But in a combination, the arrangement doesn't make any difference. The order doesn't make any difference. So I would say, all right, as far as permutations go, there's 2 of them. Because in permutations, the order is a distinguishing factor. But there's only one combination, because in terms of what a combination is, there's no distinction by order. Okay, so here we're looking at 2 permutations and 1 combination. So in permutations, the order matters, and in combinations, the order does not matter. Okay, so let's look at one more example where, again, we're not going to do any math yet. Take the symbols A, B, and C, and let's consider that you just take 2 letters at a time. So I'll pick an A and a B, or maybe I'll pick a B and a C, or something like that. I got 3 symbols, but I'm just going to take 2 letters at a time. Just so that we can understand the difference between permutations and combinations, I wanted to list them all out. Because again, like, I'm not to the point where I want to do any math yet. I just want you to understand the difference in the ideas, that you have a really firm understanding in your mind about how a combination and a permutation are different. So I'm going to have my 3 letters. I'm going to take 2 at a time, all right? And here's all the permutations. I got A, B, B, A, A, C, C, A, B, C, C, B. Those are all different because permutations are distinguished by order. But if you look at this in terms of combinations, A, B, and B, A are the same, because in combinations the order does not distinguish them. So these are the same combination. And then A, C, and C, A, those might be different permutations, but they're the same combinations. Okay, so you see. So there would be 6 permutations, count them up, 1, 2, 3, 4, 5, 6, but only 3 combinations. All right, so hopefully seeing them side by side like that helps you understand more fully the difference between a permutation and a combination. But let's give like some real examples, because so far I've just said say you have the letters A, B, and C, which might not be that meaningful to you. So real examples of permutations and combinations. A password or a PIN number, the order will matter. Okay, I can't think of any exception to that. Every password or PIN number I've ever had, that you can type the same symbols in a different order and it's going to reject it. So say my password is cat21, okay? I can't rearrange it to 1CTA2 even though that's got all the same numbers and letters. I rearrange it, it's no longer the same password. So I could say, and in terms of a password is a permutation. When you start rearranging it, it's going to be considered a completely different thing. Okay? As far as a combination, one example I can think of is a game of poker, a card game. The order will not matter. You know, you have a hand of cards when you play poker. Right here I have a 4 of a kind, okay? And I might have put it in an order with the queens together and then the 9, but it doesn't matter how you arrange it. When you put your cards down, when the hand is over, it makes no difference how it's arranged. It's still a 4 of a kind. So you could say in a poker game, like that, any hand of cards that you could have in the game, the order just makes no difference. And so we could say that combinations is the concept that's involved there. Okay, you see the difference? Passwords, PIN numbers versus a hand in a card game, permutations versus combinations. Now let's look at the formulas and calculations. Real quick, all of these will involve something called a factorial, which is in math an exclamation point. Okay? Now, so think of the exclamation point as a factorial, and the calculation for factorials is fairly simple. If I did 5 exclamation point, I would say that is 5 factorial. The way I calculate that is 5 times 4 times 3 times 2 times 1. See what you do? You start at that number and you multiply consecutively down by 1 until you get to 1. 5 factorial, if you multiply that all together, is 120. 4 factorial would be 4 times 3 times 2 times 1. Okay? So that's how factorials are calculated. It's not the only way to calculate factorials. So here I have an online calculator, and I chose this because it probably has an interface, whatever your calculator might be. It might look something like this, but every calculator is different. It's hard for me to give general advice for calculators, but there's that symbol right there. So I could do 5 and type the exclamation point and it gives me 120. So you can calculate them with a calculator directly and it's no big deal. But if you had to do it by hand, that's what it means. Okay, so here we go. My guide for calculations is the number of permutations of indistinct objects taken R at a time is, we give it by this symbol, n objects taken R at a time is n factorial over n minus R factorial. So I have n objects, but I might say I have 10 objects, I might take them 2 at a time. And I want to figure out how many permutations there are, where the order distinguishes the permutations. Okay? So when I give you these formulas, you got to think back to what permutations versus combinations are. Okay? All right. So, and then the number of combinations of n distinct objects taken R at a time. So maybe I have 10 objects, I'm going to take 2 at a time, and I want to know how many different combinations there are. Is n factorial over n minus R factorial times R factorial. Okay? So I write NPR and NCR because those are also functions in a calculator. Okay, so if I go back to my calculator interface over here, see that and that. If you have a scientific calculator, those 2 options to calculate permutations and combinations are in there somewhere, whether on the keypad or in one of the menus. Okay, but again, I can't give general advice very well because Everybody's calculator is a little bit different, but that's the key you're looking for. So you could use those keys directly, but these formulas aren't that hard to use, so I might just stick with that. So let's give an example of each of these, okay? So I want to know, if you choose among the symbols A, B, C, and D, how many two-letter permutations are there, and how many two-letter combinations are there? Okay, so in each case, we're choosing 2 objects among 4 objects. Permutations of 4 objects taken 2 at a time in each case. So using these formulas, the number of permutations, so 4 objects taken 2 at a time, would be 4 factorial over 4 minus 2 factorial, okay? And if I calculate each of these, it's 24 over 2 is 12 permutations, okay? All right, and how many combinations? If I take among the letters A, B, C, and D, that's 4 objects, and I'm going to take 2 at a time. So, okay, 4 factorial, 4 minus 2 factorial times 2 factorial. Work that out, it becomes 24 over 2 times 2, and that turns out to be 6. So there's 12 permutations and 6 combinations, okay? So I want you to think of that, in terms of this just being a matter of calculation. Maybe it's no big deal. That's how you understand those formulas. But I want you to think of it like this, that if I wrote them all out, you see this thing right here, this is the reason I gave this. If you want some kind of thinking to attach to this, imagine you had the letters A, B, C, and D. Imagine you took 2 of them at a time. Imagine that you listed them all out, just like this one. Then I'm saying that you would see before you 12 permutations and 6 combinations, okay? So I wanted to show you the math, of course, because that's part of what we do, but here's, if you want something to think about or imagine that represents what the math is describing, then it's something like this. So that's why I started with this kind of thing, all to lead up to how we do the basic calculations.